Now, use triple integral to find the volume of the solid within the cylinder x squared plus y squared is equal to 9 between the planes z is equal to 1 and x plus z is equal to 5. Okay. We already have here the illustration of the solid. Okay, if we have a cylinder x squared plus y squared is equal to 9, then it is a circular cylinder, okay, whose radius is equal to 1. Therefore, okay, we can draw the trace on the xy plane, which is a circle whose radius is equal to 1 and whose center is at 0, 0. So this will give us, we can just project it, okay, to have the circular cylinder, okay, bounded below by z is equal to 1 and above by x plus z is equal to 5. Okay, by the way, if we have the x-axis and the z-axis, consider this as the z-axis and this one is the x-axis. If we have x plus z is equal to 5, the x-intercept is 5 and this is 5 and the z-intercept is also 5. So the plane is this. This is actually the plane, okay, cutting the circular cylinder. And you can see here the upper base of the cylinder, which is the plane x plus z is equal to 5. This is x plus z is equal to 5. And of course, if we will find the solid, the volume of the solid rather, then we have to draw the element here. So just draw the element. This is the base, okay, and we will simply draw a rectangular box here, okay, which will serve as the element. So on the lower base, just draw a rectangular box. Okay, this is the rectangular box. Okay. Okay, I will just draw the rectangular box here. Okay, and this is dx, dy, dz. The volume of this rectangular box is the differential of v, okay, which can be taken as dz, okay. Then we decide whether it is vertically simple or horizontally simple. Okay, we may take it as dy dz or dx dz. Let us just have it as vertically simple, okay, dy dz. So going back to the rectangular region R on the xy plane, since we consider the order dy dz, then we can just draw a vertical line, okay, and this is the representative element. So it means that we will go down, up, then left to the right, okay. So since we have a circle, x squared plus y squared is equal to 9, we can solve for y, and then y is equal to, okay, actually we can have this as y squared is equal to 9 minus x squared. So getting the square root of both sides of the equation will give us y is equal to positive square root of 9 minus x squared and negative square root of 9 minus x squared, okay. The lower end is y is equal to negative square root of 9 minus x squared, and the upper end is y is equal to the square root of 9 minus x squared. Hence, if we will get the volume of the box, okay, let me use the blue ink. If we will get the volume of the box, okay, this box, okay, the volume is equal to the differential of v. Now, if we will get the triple integral or evaluate the triple integral over the region G, okay, where we will take the differential of v equals dz dy dx, then the volume is equal to the triple integral of the differential of z, differential of y, differential of x. Okay, so we can now have the interval in G, okay, in the region, okay, sorry, we use the region R. So the region R, sorry, in the xy plane. Okay, so the region R in the xy plane will give us y, okay, y will go from negative square root of 9 minus x squared, negative square root of 9 minus x squared, okay, to positive square root of 9 minus x squared. And of course, x will go from the leftmost, negative 3 to positive 3. Okay, and if we will consider, of course, the region G, we have to include the interval of z, and z will go from z is equal to 1, okay. Take note that the solid is bounded by, okay, z goes from z is equal to 1 to uh, z is equal to x squared plus y squared minus 9. Okay, so, sorry, this should be z is equal to 5 minus x. Okay, so we will solve for c here. C is equal to 5 minus x. And the element will go from the lower base, z is equal to 1, to the upper base, z is equal to 5 minus x. So we can now write the limits of integration. C will go from 1 to 5 minus x. Y goes from negative square root of 9 minus x squared to positive square root of 9 minus x squared. And x will go from negative 3 to 3. Okay, hence we have integral from minus 3 to 3. Then we have negative square root of 9 minus x squared to positive square root of 9 minus x squared. Okay, the integral of the differential of z, okay, which is the innermost integral, okay, is z, and we have to evaluate z from z is equal to 1 to z is equal to 5 minus x. Hence, this is equal to, okay, we have integral from minus 3 to 3, okay, limit of integration in x. Then in y, negative square root of 9 minus x squared to positive square root of 9 minus x squared. Okay, sorry, there must be dy dx here. And when z is equal to the upper limit 5 minus x, then we have 5 minus x minus z, lower limit z is equal to 1, so minus 1 dy dx. Okay. so this gives us, wait, this gives us a double integral minus, or y goes from, x goes from -3 to 3. Y goes from negative square root of 9 minus x squared to positive square root of 9 minus x squared. And if we will simplify 5 minus x minus 1, that gives us 4 minus x dy dx. Okay. And since x is temporarily held as constant, if we will do the inner integral, then 4 minus x is constant, and the integral of dy is y, where y will go from negative square root of 9 minus x squared to positive square root of 9 minus x squared times the differential of x. Okay, hence, that will give us the integral from -3 to +3 of quantity 4 minus x times. Okay, when y is equal to the upper limit square root of 9 minus x squared, so that gives us square root of 9 minus x squared. Then minus the value of y at the lower limit negative, so negative will give us positive. Square root of 9 minus x squared times the differential of x. And square root of 9 minus x squared plus square root of 9 minus x squared will give us 2. Okay, so we have the integral from -3 to +3. Okay, so that gives us 2 times 4 is 8. Okay, so 8 times the square root of 9 minus x squared. Okay, then minus x times the square root of 9 minus x squared times the differential of x. So we can express this as sum of two integrals. So if we will express this as sum of two integrals, then we have 8 times the integral from -3 to +3 of the square root of 9 minus x squared times the differential of x, then minus the integral from -3 to +3 of x times the square root of 9 minus x squared times the differential of x. Now, the first integral can be evaluated by trigonometric substitution. Okay, and the other integral can be evaluated by power formula. So just continue the integration in x. Okay, first integral by using trig-sub, and then later you can actually use the Walsh formula, and then we have the second integral, which can be evaluated by power. And